Hello everyone, welcome to 30 Days Data Science Project Bootcamp series. Today we are going to start our third project called Machine Learning. And in this particular project that we are going to build a end-to-end machine learning pipeline where we are going to cover a data ingestion, data validation, data transformation, model training, model evaluation and model pusher. All 6 pipeline that we are going to cover in this particular project with integration with MLFLOW. So at the end that we can integrate our machine learning project, this particular project with MLFLOW. Okay, so let's first of all try to understand a problem statement. After understanding a problem statement, then we can understand our complete project architecture and then we can build our entire machine learning application and then we can integrate with MLFLOW. So the problem statement that we have, this data set includes descriptions of hypothetical samples corresponding to 23 species. Each species is identified as definitely edible or definitely poisonous. So we have one data set and in our data set we have a 23 features. Now in our features we have one column called classes and in our classes we have two types of the data. First is a edible and the second that we have the poisonous. Okay, so the main objective that we have for this particular problem statement, the objective is to create a model that can predict edibility of the mushrooms based upon the features, whatever the 23 features that we have in our data set. Now if I talk about the data, so here that I have mentioned the Kaggle dataset link, so you can just download a dataset from this particular link. So you can just click on this particular link and after that you will get a complete data link here. So from here that you can download your dataset. Okay, so this is the mushroom CSV dataset that we are going to use. Okay, now if I talk about the all the datasets features, so here we have our complete columns name, we have our complete description and we have the values, whatever the values that we have in our every features. Okay, so the main objective that we have, the main objective is to create a model that can predict edibility of the mushrooms based upon its features. So let's try to understand our complete features, whatever the features we have in our dataset. So the dataset features, first we have the columns name, a description and the values. So the first columns name that we have the classes, in our classes that we have the two, because this is the target feature that we have, a target column that we have. So in our classes that we have only two types of the value that we have, edible or a poisonous. Okay, so E equal to edible, P equal to poisonous. Okay, so we can say this is a binary classification problem statement that we have. Okay, now second column that we have a C, cap shape. So the shape of expanded upper part of the mushroom. So B, bell, C, canonical, X, convex. Going forward I will show you the images as well. Okay, so like which types of the bell mushroom image that we have, a canonical, a convex, flat. Okay, so each and everything that I will show you in our upcoming time. Okay, so first we have the bell shapes, B, C, canonical, X, convex and the so on different value that we have in our cap shape mushroom features. Next we have a cap surface, so the structure of the upper part of the mushroom where we have a F, figures, G, grooves, Y, S, smooth, so on different value that we have in our cap surface column, a different value that we have. Cap color, so the color of the surface of the upper part of the mushroom, so brown, buff, canonical, gray, green, pink, purple and the so on other value that we have. Now next have brushes, indicates of 3 are brushes on the, there are brushes on the mushroom. Okay, where we have a two types of the data, two types of the value, yes, T, F, no. Okay, now we have a odor, so the smell of the mushroom, again we have a different types of the smells. Gill attachments, the way the gill is growing on the mushroom attachment descending, free, and not. So different value that we have. So on. Here that I have mentioned all the columns name, all the descriptions, as well as all the values, whatever the value that we have associated with those particular columns. Okay, so each and everything that I have mentioned here. So main target column that we have the class, this one, where we have a two types of the description, edible or poisonous, E equal to edible and P equal to poisonous. Okay, now if I show you the mushroom structure, so this is the complete mushroom structure that we have. This particular image is look like this one. Okay, so we have a different types of the here features. Okay, so first, as you can see, this is the complete context that we have. After that, we have the inner veil, we have the universal veil. Okay, so this particular line is pointed as a universal veil, a inner veil. After that, we have a volvo, strip. Okay, now gills. So different features. In a different features, we have a different pointed here. Okay, so mushroom, our complete mushroom structure look like this one. Now if I show you the mushroom cap shape, so as you can see here, if I show you again, so mushroom cap shape, where we have a different types of the value, a veil, canonical, convex, flat, and the so on. Right, now if I show you the image, so convex look like this one, veil shape look like this one, a canonical look like this one, okay, flat look like this one, sunken look like this one, so on. We have a different types of the shape. Now we have a cap surface, so it smooth, velvety, hairy, ridged, flat scales, patches. So different types of the surfaces that we have, mushroom surfaces that we have. Now mushroom gill attachment, so attached. Now we have the adent. Okay, so different types of the gill attachment here that we have. Now if I show you the gill spacing, so again crowded, close, distant. So different types of the spacing, gill spacing that we have. Now mushroom gill tissues arrangement, so again parallel, and the so on, different things that we have. Now stalk types, so again equal, club shape, ball bones, with cups, rooting. So different types of the stalk type that we have. Now ring type, so again in a ring type that we have the pendant, fairing, sitting, double. Okay, so different ring type that we have. Okay, so these are the some of the images that we have based upon our features, whatever the features that we have in our data set. Okay, so the main problem statement that we have, a main objective that we have to create a model that can predict edibility or the poisonous based upon the mushroom features. So this is the main problem statement that we have, and based upon our problem statement, we have these are the some of the features, a total 23 features that we have, and based upon these particular features, these are some of the structure that we have, or we can say some of the images that we have based upon our features. Because see, after understanding the problem statement, we can't directly start our building a complete model. No, first of all we need to understand in depth our problem statement. So now we are able to understand, okay, so in a like mushroom shape or in a mushroom surface, like which types of the surfaces that we have in a mushroom, which types of the shape that we have in a mushroom, which types of the attachment that we have in a mushroom, which types of the gill spacing that we have in a mushroom. Okay, so we are able to understand each and everything. Okay, so based upon this particular problem statement, based upon this particular features, we are going to build an entire ML application where we can classify whatever the features that we are going to select. Based upon those features that we have a edible or we have a poisonous mushroom. Okay, so this is a main problem statement that we have. Now hope you are able to understand a complete problem statement. Now what I'm going to do, now let's try to understand a complete project architecture. So here, as I mentioned, a project pipeline automation. Okay, so we are going to understand this particular complete project architecture. So let me zoom out little bit so that you can see each and everything in a detail. Okay, so yes, this is a complete project pipeline structure that we have, and based upon this particular project pipeline structure, we are going to build our entire ML application. Now let's try to understand this particular complete image. So let's start with this one. So as you can see here, we have two things. So we have a experiment, development, test. Second, we have a staging, pre-production and the production. Okay, so whatever the below part that we have, this particular complete below part that we have the staging, pre-production and the production, and whatever the upper part that we have the experiment, development and the test. Okay, so let's try to understand first of all the experimentation, development and test, and then we can understand staging, pre-production and the production. Okay, so experimentation, development, test. So let's say if as a owner of any company, XYZ company or the ABC company, that we are building one of the application. Okay, now I have a plan. After 1 week that I want to launch this particular application over any platform, like over the Android or over the like iOS, any types of the application that we can publish, okay, based upon our use cases. Okay, now what I have a plan, after 1 week that I want to publish this particular application over the Google Play Store, okay, so that our all the users they can use it. So what we can do in the experimentation, development, test, as I have a plan after 1 week to launch this particular application publicly over the Google Play Store. Now what I can do, I will try to launch this particular application before within a 3 and 4 days before launching, before a final launching. Okay, so let's say after 1 week, it means before 3 and 4 days I will try to launch this particular application, okay, to our internal team. Let's say in my company that I have 100 members. Okay, so I will try to launch this particular application to my internal team only, so that my all the internal teams they can download this particular application from Google Play Store, and after that they can use it. Then whenever they are going to use this particular application, and whatever the issues they are facing, whatever the works they are getting, okay, so what we can do, first of all, that we can try to resolve this particular issue or whatever the bugs our users or our internal team members they are getting. So first of all, we will try to resolve this particular issue or those bugs, and then we can publish or then we can launch our application for a final production, so that all the users they can download this particular application from a Google Play Store and then they can use it. Now here we have two things. First, development, experimentation, development and test. In a experimentation, development, test, that we can say that we are going to launch a beta version of our application, so that in a beta version of our application, our internal company team member they can download this particular application, they can use, and after that they can come up with the issue, they can come up with the box, whatever the issue or whatever the box they are getting in the application, then we can resolve this particular issue, then we can resolve this particular box, and then we can release our final application for a final production, so that our all the users they can download from the Google Play Store, and after that they can use this particular application. So we have two things. First, experimentation, development and test. In a experimentation, that we are going to launch a beta version of the application, and in a beta version only our internal company team member they will get access for this particular application in a beta version. Now if I talk about the staging, pre-production and the production, so in a staging, pre-production and in a production environment, that we can publish this particular application to our all the users publicly, that we can launch this particular application over the Google Play Store, so that the any user they can download and they can use it. So one benefit that we have in the experimentation, development, test, or we can say the beta version, launching a beta version of the application, so that whatever the issue, whatever the bugs our internal team members they will get, that we can resolve those particular issue, and then we can launch a final application to all the public. Okay, so this is the two scenario that we have here. Okay, now I hope you are able to understand this particular things. Now what I can do, as you can see, now we are able to understand the experimentation, development, test and staging, pre-production, production. Apart from this one, we are able to understand our complete problem statement. After understanding a problem statement, we need a data, right? So here we have one stage called feature storage. So let's say this particular feature storage that we can say that, okay, so this is the cloud platform that we have, or we can say this is a databases that we have, or this is a central repository that we have over our GitHub, and our data sets are available in this particular feature storage. So if I open my notepad, so I can write here a feature storage. Okay, now in a feature storage that we can say, okay, so this particular in a feature storage that we have our complete data set, and this particular data set that we can say the feature storage like a cloud, any types of the cloud, or any types of the databases, or we can say the any types of the central repository, a central repo. Okay, a central repository. Okay, so our data sets are available on somewhere on the cloud, or somewhere on the databases, or somewhere on the central repository. Then we can say, okay, so that our data sets are available over the feature storage. Okay, now we are able to understand, okay, so our data sets are available over the cloud, or a databases, or a central repository over the GitHub. Now what we can do, now we are able to understand, okay, so our data sets are available here. Now what we can do, first of all, that we need to extract our data. First of all, we want to ingest our data in our local system, because whatever the data that we have right now, this particular data sets are available over the cloud, or the databases, or the central repository over the GitHub. So first of all, that we need a data to work on this particular project, or to build this particular complete ML application. We need a data, right? So what we can do, first of all, we need to extract the data, or first of all, we need to ingest the data from any sources like cloud, or the database, or a central repository. So the first step that we have, extract a data in our offline system. First steps. Now after extracting a complete data, then we can perform some of the data analysis in our Jupyter notebook, where we can do the complete EDA, we can perform the data pre-processing, we can perform a feature engineering, and based upon this one, we can build an entire model in a Jupyter notebook. I am talking about the Jupyter notebook, a complete analysis part that we can do in a Jupyter notebook. Okay, after that, what we can do, now we are able to get our complete data in our local system, in our offline system, in our laptop. Okay, after that, we are able to perform a data analysis, and based upon this particular data analysis, that we are able to get some of the understanding based upon our data. Okay, so we are able to understand our complete data here with the help of a data analysis. Okay, now we have our complete data, we are able to perform some of the data analysis. Now after that, what we can do, we can validate our data. So in our data validation, what we can do, we can validate our data name, we can validate our columns, complete columns, we can validate our complete features name, whatever the features name that we have. Okay, I will tell you why we are going to do these types of the validation. Okay, so what we can do in a data validation, first step that we have a data extraction. Okay, so for the first step that we have here, let me write it down here. The first step that we have after getting a data, so after getting a data, first step that we have to do a data validation. Again, here that we are going to perform a data ingestion, where we are going to ingest the data, or where we are going to extract the data from the cloud, or from the databases, or from the central repository. Now in a data validation, what we are going to do, the first of all that we are going to validate our file name, whatever the dataset file name that we have. After that, we are going to validate a features name. Okay, a features name that we are going to validate. After that, we are going to validate a features, a data types. Okay, so these are the some of the important things that we are going to validate, where we have our file name, where we have our complete features name, where we have our features data type. Now let's try to understand why we are going to do the data validation. So whenever we are working in a real time, whenever we are working in an industry, so mostly that we are mostly we are getting a data on the monthly basis, or on the quarterly basis, or on the yearly basis. Let's say a monthly basis that we are getting a data. So whenever we are getting a data from our client, so every time that we will get the new data over our client, over our cloud, or over our databases, or over our central repository. So again that we need to fetch a data. Okay, so let's see, by mistake our client, they have uploaded a different types of data. Let's first of all try to think original data. So whatever the original data that we have, in our original data that we have total, let's say the file name that we have, the abc.csv. Okay, so abc.csv file name that we have. Now if I talk about the features name, so we have a features name called, let's say the like A to Z, total A to Z features name that we have. Okay, now in a features name, after that we have, let's say 24 features that we have, a 24 total features that we have, a total features that we have. If I talk about the features data type, so total, if I talk about the 10 features that we have, numerical, 10 features that we have, a categorical, and 4 features that we have, a date time. Okay, so this is the features, or this is the complete information that we have for our original data. Okay, now after 1 month, again I got one data from my client. Okay, so after 1 month, new data set I received from my client. Now here, whatever the data set name that we have, let's say the data set name that I have, xyz.csv. So yes, it's possible sometime that even as a developer that we save our data as a xy, like anything, any name that we can save. So first condition that we can satisfy with the any name. Okay, first thing. Second, whatever the data I received from my client, a new data, here I have let's say the 20 features that we have, but we have trained our model over the 24 features. So again, we have some of the mismatch features in our data. Now let's try to talk about the next part, where we have a feature data type. So whatever the 20 features that I have received, so in this particular 20 features, I have 8, let's say the 8 numerical, 8 6 categorical, and 6 date time. Again, we have a feature mismatch. Second, we have our complete data type mismatch. So in this case, again, we can't directly use this particular data over our previous model, because our previous model trains over our 24 features. But in our new data, we have only 20 features. So we have some mismatch in our data set. That's why we are going to do the data validation, because as you can see here that I have mentioned a project pipeline automation. Here we are not going to check every time manually. We are going to build the entire pipeline, so that whenever we will get the new data, we can just trigger our machine and automatically our all the pipeline, it will get completed. So that's why we are going to do the data validation here, so that if any changes or any modification that we have in our data set, our application, it will throw a error. Okay, now we have a next step called a data preparation, or we can say a data transformation. So what happens in a data transformation? After doing the data validation, in a data transformation, that we can apply a complete data pre-processing steps and the complete feature engineering steps, where we can handle the missing value, we can handle the outliers, we can handle the categorical data, we can handle our imbalance data. So these are the things that we can handle in a data preparation steps. After data preparation steps, now our data sets are ready. So whatever the data sets are ready that we have, now what we can do, we can apply a multiple machine learning algorithm. So model training that we are going to apply with the multiple machine learning algorithm. After that, let's say that we are going to use a 4 machine learning algorithm. So based upon this particular 4 machine learning algorithm, what we can do, we can do the complete model evaluation, and after the model evaluation, then we can select a one final model, because that we are using a 4 different machine learning algorithm with the different parameter. Okay, so first steps, train model, then evaluate the complete model, and after that we can select a one final model, so that the final model that we can put it down for a final deployment purpose. Okay, so data preparation, after that we can do the model training with the different machine learning algorithm, we can do the model evaluation, and then we can validate our machine learning model, a final validation, a final model that we can select. After that, what we can do, we have one of the source code repository in our system, so we can put it down each and everything in our source code. After that, we can push this complete code, this complete pipeline code over the source repository, or that we can say a central repository over the GitHub. Okay, it depends upon the clients, like whatever the source that we are using. Okay, so we can push our complete code or complete pipeline over a source repository, and from this particular source repository that we can set a pickle file, or we can take a pickle file to do a complete deployment. Okay, so this is a complete orchestrated experiment pipeline that we have. Okay, now here we have our complete pipeline. Now the next step that we have here, the automated pipeline. This is the orchestration pipeline that we have, where we are going to do one by one each and everything manually: data extraction, data validation, data transformation, model training, model evaluation, and the model validation. Now next that we have a automated pipeline. So in a automated pipeline, what we can do, whatever the data that I have trained, whatever the final pickle file that we are getting here, we are going to do the deployment based upon this particular final a pickle file. Whatever the pickle file that we have here in our source repository, based upon the pickle file that we are going to do the complete deployment. And now as you can see, this is the arrow that we are getting in our automated pipeline. Okay, so based upon this particular pickle file, whatever the final pickle file that we have selected, now what we can do, whenever we will get a new data from my client, we can just trigger our machine, and automatically all the pipeline, it will get completed. Again, pipeline completed, it means again whatever the new data that we are getting, our new data available out on cloud platform or a databases or a GitHub, right? So first of all that we need to fetch a data, so data extraction. After fetching a data, we are going to do the data validation, then data preparation, model training, model evaluation, and the model validation. After doing a model validation, now what we are going to do, whatever the pickle file that I received, we can store over the model registry folder. Why that we can store over the model registry folder? So let's assume here whatever the previous model that I have here, here that I have a 90% of the accuracy model. Okay, now what we are going to do, whenever we are getting the new model, again that we are going to trigger our machine, again that we will get the new model. So here let's say that we are getting a 88%, let's say the 80% of the accuracy that we are getting, 80% of the accuracy, model accuracy that we are getting. Now what we can do, again that we can put it down the 90% of the accuracy model in a final production, because this is the best accuracy that we have, right? Now what we can do, again after some time, a second month or the third month, again that we receive the new data from our client, again that we are going to trigger our machine here. Okay, now this time if I talk about the second time, so second time that I receive, let's say the 93% of the accuracy. Okay, so now what we can do, both the model, the previous one as well as the new model that we have here, so total 2 model that we have here in a model registry. Okay, so from here that we can select the 93% of the model, 93% of the accuracy model, and then we can put it down for the final deployment purpose. And then whenever we will get the new data, we can just trigger our machine, and then we can run our entire pipeline. Apart from this one, we have some more things here. So after deployment, that we can create our complete web application, where we can test a complete application, single prediction, or we can say the instance prediction or the batch prediction. Apart from this one more thing that we have, the performance monitoring. So in a performance monitoring, that we can capture all the information, we can capture the log, we can capture, okay, so how many people they are visiting over our website, whatever the application that we have built, a ML application. Let's try to talk about with the one of the example, this particular performance matrix. Okay, so as I am running a success analytics website. Okay, so what I can do in a success analytics website, we can track all the information. Okay, so how many students, how many users they are visiting our platform, our success analytics platform. Apart from this one, how many students, which types of the courses they are going to check, they are going to view. So we can capture entire information. Apart from this one, that we can capture or we can monitor, okay, so ABC or the XYZ student, they are interested in ML bootcamp or the NLP bootcamp courses. After that, they are going to check the only syllabus, or they are planning to enroll. How that we can capture? So whenever our users, they click over a enrollment link, we can capture our complete information. So in a performance monitoring, that this is the one of the example that I shown you, but yeah, in a real cases depends upon our application, that we can monitor each and everything. Okay, so how many users they are visiting on our platform, how many users, like which types of the activity they are doing over our platform. So those things that we can monitor here, each and everything that we can monitor. Okay, so based upon this particular pipeline that we are going to build our entire application, entire mushroom classification application with the integration with MLFLOW. Okay, now if I talk about the complete pipeline, so as I mentioned, we are going to cover data extraction, where we can extract the data from the different sources, cloud or the database or the central repository called GitHub. Okay, so we can select only one thing. The later part in our upcoming videos, if I will get the good responses in a comment section, then definitely I will come up with the cloud as well as a databases. Now after getting a data in our offline system or in our laptop, then we can do the data validation, where we can validate our data name, we can validate our features, we can validate our features data type, so each and everything that we can validate, and many more things. Now data preparation, where we can work on the data preprocessing and the feature engineering, then we can train our model, after that we can evaluate, and then we can select a final model, and based upon the final model then we can do the deployment. Okay, so yes, this is all about our complete project pipeline. Based upon this particular project pipeline that we are going to build an entire application. So let's start building our entire application. Now we are going to build our entire project. So this is a complete project folder structure that we have, and in this particular project folder structure we have some of the files, we have some of the folders. Okay, now in every folders and in every files that we have some of the codes, so we can understand all the codes line by line. We can discuss each and everything a line by line. Okay, now let's start with this one. So as you can see, this is the complete project folder structure that we have, and in this particular project folder structure we have two things, folders as well as files. Okay, main project directory that we have, the mushroom classification project with MLFLOW. So this is the main project directory that we have. Now in this particular directory we have folders, we have files. So whatever the folders and whatever the files that we have here, we have a two way to create all the files as well as all the folders. The first way that we have, we can create all the files and the folders manually, one by one. So as you can see here that we have the option to create the new file, and we have the option to create the new folder. This is the first way that we have, but it will take a lot of time, because as you can see here multiple folders that we have. In every folders we have a multiple files. Apart from this one, as you can see, every folder that we have the multiple folders and the multiple files that we have in our every folders, and in our every files that we have the multiple 100, 200, 300 lines of the code that we have in our all the files. Okay, so first way that we can create all the files, all the folders manually. Second way we can write a Python script, and with the help of Python script we can create all the folders, all the required folders as well as required files. Okay, so here that I have created a template.py file, and in this particular template.py file, this is the complete Python script that we have, and with the help of this particular Python script that we are going to create all the necessary project file as well as folders, whatever the project files and the folders that we have required for this particular project. So first of all, what we are going to do in a template.py file, we are going to import our all the library like OS. From the path lib we are going to import a path, so that we can define, okay, so we want a folder or the file under our main project directory. After that logging that we have, so in the logging that we are going to call a logging.baseconfig. Here we are going to define info, logging.info, a format that we are going to call, so ASCII time as well as a message that we are going to call. Okay, now we are going to define a project name, so project name equal to the mushroom project name that I am going to call here. After that we have created a list, so list of the files, and in this particular list that we are going to define our all the folders as well as all the required files. Okay, so what we are going to do under this particular list of the files, so first we are going to create the src folder. So yes, here as you can see we have the src folder. Under the src folder we are going to create a mushroom project folder. So if I show you here, so yes, we have a mushroom project folder under our src folder. After mushroom project folder, we are going to create a multiple folders and the multiple files. So first we are going to create underscore ini.py file. Let's verify. So as you can see here we have our underscore ini.py file. Now we are going to create some of the folders called components, utils, config, pipeline, entity and the constant. So components, config, constant, entity, pipeline, utils. So these are the folders that we are going to create. Now we want some file as well. So underscore underscore init, in every file that we want some of the files. So again in a config that we want a configuration.py file. So if I show you here, so you can see under the config folder we have our configuration.py file. Under our utils folder that we have the common.py file. So if I show you, so yes, under our utils folder we have our common.py file. So so on. If I show you the entity folder, so under the entity folder we have our config entity.py file. So whatever the required files and the folder that we need, first of all we are going to define like this one, where under the src folder we are going to create our main project folder called mushroom project, and under this particular mushroom project folder we are going to create some of the files as well as some of the folders, required files and the folder we are going to create. Apart from this one, we need some more files. So config folder that we are going to create. So here config, and under the config folder that we are going to create a config.yml. So yes, config.yml. After that, schema.yml, a params.yml. So yes, params.yml, schema.yml, a main.py file, app.py file. So main.py file that we have the app.py file, that we have docker file, requirements.txt, setup.py file. Apart from this one, research folder we are going to create. Under the research folder we are going to create a trials.ipyonv file, templates.index. So right now I did not have a template because I already deleted those things. So let me remove this particular part from here. Okay, if you want you can just define it. Okay, so these are the list of the files and the list of the folders that we are going to create. After that, here we are going to write a complete for loop. So for file path in the list of the files, so from this particular list of the files we are going to call a file path. Now file path equal to path, so this is the library that we are going to call, and after that we are going to split our folder as well as a file. So as you can see in this particular list of the files we have some of the folders as well as we have some of the files. So what we are going to do, we are going to split, so file directory comma file name. So we are going to split our directory and file, both the things that we are going to split. Okay, now after that, here the condition that we are going to write, if file directory not equal to empty, in this case that we are going to create a directory. So os dot make directory, a file directory that we are going to create, and if it's exist, in this case that we can return exist okay equal to true. So logging that we are going to capture, so creating a directory for the file name, whatever the file name that we are going to give. So this is the first condition that we are going to write. So if the file directory is not empty, in this case that we are going to create a file directory folder. Now second if condition that we have, so if not, as you can see here that we are going to apply two condition. Okay, so not os dot path dot exist if our this particular path is not exist, or I'm going to apply or operation, os dot path get size of file path equal to 0. It means whatever the main project directory that we have, if this particular file is not exist as our file path equal to 0, it means we did not have anything, any folders or any files. In this case what we can do, we can open our file path. What is the file path? Mushroom classification project with the MLFLOW. So this is the file path that we have, and then w it means that we are going to do the write operation. Write, it means that we are going to create this particular folders and the files. Okay, so we are going to perform the write operation, and then here that we have the login info, creating the empty file. So if this particular things is done, in this case that we can return okay, so creating a file is empty. Okay, and after that else statement that we have, so file name is already exists. So this is a complete condition that we have. So based upon this particular condition, first of all we are going to split our folders as well as our files, and after that we are going to create a directory, and in a directory we are going to create our all the directory as well as all the files and all the folders, whatever the list of the files and the list of the folders that I have mentioned here. Okay, based upon this particular for loop that we are going to create each and everything. Okay, so this is the Python script that we have, and based upon the Python script we can generate our all the files and all the folders, whatever the required files and the folders that we have for this particular project. After that we have our setup.py file. So let's first of all try to understand what is setup file and why the setup file is required. So setup file, let's say that we are building any types of the application, Python application that we are building, and after some time that I have a plan to publish this particular application as a library, a PyPI library like pandas or the numpy or the c1 or the matplotlib. In this case our setup file, it will help us. So if we have a plan to publish any types of the application as a package, in this case we need a setup.py file. Okay, and this particular setup.py file, it will help us to publish any types of the packages. Okay, so what we are going to do, first of all we are going to import a setup tools. After that we are going to open the readme file. So if we want, in this case, that we can open, and then we are going to read our all the description from the our readme file. So if you want, you can add it. Okay, now after that what we are going to do, so this is the complete version that we have. So as we all know, whenever we are going to download or the install any types of the library like NumPy or the Pandas or the Matplotlib or the Shivon, we have a different types of the version, different types of the version that we have. So every version that we have the new features, in all the Pandas version we have a different features, right? So if we are going to release our packages first time, in this case that we can define a version. Let's say if I have done the little bit modification after releasing a package, in this case that we need to change our version every time whenever we are going to do the modification or whenever we are going to add any types of the features in our application. So we need to do the modification in our version. Okay, after that here that I'm going to give my repo name. So repo, or you can say the project name that I'm going to give. So mushroom classification project with the MLFLOW. Author name, author username, so Shivan1018. So this is my GitHub ID that I have. Username, you can write any author name, it's not important you can write the only your GitHub ID. No, you can write any name, it's totally up to you. Username Shivan Kumar, author email ID, so dummy@gmail.com, dummy email ID that I'm going to give. Now here that we are going to create a setup. So setup tools dot setup, where we are going to give the name, a version, author name, author email ID, description, long description from our readme file. Okay, long description, context, then packages that we are going to find where under the src. So under the src that we have our package called mushroom, and here that we have our package called underscore ini.py file, and then we are going to find our complete packages. Okay, where under the src folder we are going to find our complete packages. Okay, so in this way we can define our complete setup.py file. Okay, apart from this one, let's say that we have under the requirement.txt, if I show you here, so here as you can see we have all the requirements. Now we all know whenever we want to print something in a next line in a Python. So let's say if I want to print first 10 digit number. Okay, so first 10 digit number that I want to print. So let's say that we have the output like this one, 1 2 3 4 and 10 all the output that we have. Okay, so all the output that we have. Now as you can see all the output that we have in a next line, in this case whenever we want to print something in a next line in a Python, that we are writing a /n, right? So as you can see in a requirement.txt, everywhere /n is a hidden that we have, everywhere /n is a hidden that we have, because all the requirements that we have in the next line, and whenever we want to print something in the next line in a Python, we need to call a /n, right? So if, as you can see, if we want to delete this particular /n from our requirement.txt, in this case we can write a for loop, and based upon the for loop that we can delete this particular /n. Okay, so it's totally up to us. If we want, we can delete it. Okay, but it will be good that we can delete, but right now that I have not added a code, it's totally up to you. If you want, you can just write a complete for loop, and based upon the for loop that you can delete. Okay, now let me remove this particular /n from everywhere. Okay, so our setup.py file, it will help us whenever we want to release or publish any types of the package over the PyPI library. Okay, in this case our setup.py file, it will help us. Okay, now after understanding the setup.py file, what we can do, we can set up our complete this particular project. Okay, so in a readme.md file that I mentioned the complete details. Okay, so first of all what you need to do, you need to create the new environment. So we have a command conda create -p env python equal to 3.9. make sure you can use the 3.9 version. Okay, -y. So with the help of this particular command, first of all we need to create the new environment. After creating a new environment, we need to activate the environment. So let's say if you are using a Windows operating system, in this case we have a command conda activate env/. Let's say if you are using Linux or Mac operating system, in this case that we have the command source activate env. Okay, after activation of the environment, then we need to install our requirement.txt. So pip install -r requirement.txt. Then if you want to train your complete machine learning projects, in this case that we have our main.py file. Okay, so you can run your main.py file. Else, let's say if you want to run your application, in this case you can just call streamlit run application.py file. Okay, so make sure try to set up your system first of all with the help of this particular command. Okay, so that we can good to go. Okay, so this is the complete command that we have. Based upon this particular command, you can do the complete setup. Now after doing the complete setup, then we can install the requirement.txt and then we can run this particular application. But before running the application, that we need to build the entire application, right? So now let's try to build the entire application. Okay, so what I'm going to do here, I'm going to create one of the txt file. So project flow dot a txt. So this is the file that I'm going to create, and in this particular project flow.txt, I will write our all the pipeline flow structure or the pipeline structure. So as I mentioned, the first we need a data. Okay, first we need a data. Now our data are available over the cloud, our data are available over the databases or the central repository called GitHub. So first of all, we need to fetch a data. Now in which step that we need to fetch a data? In a data ingestion steps. As you can see, a data ingestion step that we need to extract the data from the different sources. So first operation we need to perform here a data ingestion. First operation we need to perform a data ingestion. Okay, after that, as for the pipeline, data validation, then data transformation and so on, model training, model evaluation and the model validation. Let's try to talk about first of all a data ingestion. So in a data ingestion, first of all we need to define our complete repository, or we can say the cloud access, or we can say the database access link. Okay, our user and the password complete. So what we are going to do, first of all that we can write a code under our config.yml file, where we can define, okay, so we are going to access a data from the databases or from the cloud or from the central repository called GitHub. So first we can write a code over the config.yml file. Now in a config.yml file, that we can create the object, and based upon the object we can define variables as well as a values. Okay, after writing a code under the config.yml file, then we can define our entity. So config entity, so then we can write a code under the config entity where we can define, okay, so which types of the output that we are going to expect apart from this one, how that we can join our entire path. Okay, so we can write first config entity, config yml, then config entity. After writing the config entity, then we can define our variables under constant file. Okay, after that we can define our complete variable under the constant file. Then we can join our complete path under our configuration file. Then fifth, if required, we can create a helper function. Okay, so utils file, under the utils folder we have one file called common.py file. So if I show you here, so as you can see, under the utils folder we have our common.py file. So helper, this is the utils folder, it works as a helper function. Okay, in a description section I'm going to provide you one of the doc file where I have mentioned each and everything in a detail. What is config file, what is config entity file, what is constant file, what is configuration file, what is utils file, and why we are going to use this particular file. Okay, so make sure you can check it out, a description section where I have mentioned a complete 20 pages PDF file in a detail. You will get the better understanding what is config, why we are going to use a config, what is config entity, why we are going to use a config entity file, what is constant, why we are going to write under the constant file a code. So each and everything that you will get the better understanding. So make sure check it out, a description section, a complete PDF file link. Okay, so utils folder is works as a helper function. So let's say if I want to read a YML file, we can create a helper function, and whenever I need, we can use this particular function. So this particular helper function, it will help us to reuse our code again and again whenever I want. No need to write again and again same code. We can create a function, and whenever I want, I can use a same code, or we can say we can reuse a same code again and again. Okay, now after creation of the helper function, then we can write a code under the data ingestion file, under our components folder. Okay, then we can define our pipeline. So we can define our training pipeline. Okay, so now we are going to run our first training pipeline called data ingestion, same data validation, same data transformation, and so on for our all pipeline. And then we can test our complete test first pipeline called data ingestion. Okay, so in this way we are going to write our complete code. So let's try to understand. Same way we can write a code for the data validation, data transformation, model training, model validation, and the model pusher. Okay, so let's try to understand one by one. So here, as I mentioned, config file. First we need a config file, but before this one, two more major file that we have here. So if I talk about this one, okay, so let's talk about later, not now. Okay, so we can talk about later these things. Okay, so let's start with the config.yml file. So here that I have a config.yml file, and under the config folder we have our config.yml file. Let me open. Now in this particular config.yml file, as you can see, if I show you here, so first of all that we are going to create a directory, a artifact root directory we are going to create. Okay, so the artifact folder that we are going to create. Now after creation of the artifact, so as you can see here that we have the artifact, so this is the artifact directory that we are going to create with the help of this particular variable. Okay, we can join this particular file many other files, like in the data ingestion, validation, transformation, and model training, and so on. I will show you later. Okay, so let's try to discuss one by one all the codes line by line. Okay, so first here we are going to create a variable root, artifact roots, and this is the value that we have. Okay, so artifacts is a value that we have, and this particular artifacts is a directory we are going to create. Okay, a root directory where we can store our all the output information. Okay, now here that we are going to call our first pipeline called a data ingestion, or you can say that we are going to create a object for our data ingestion. Under this particular object we have a many variables and the values. So the first variable that we have the root directory. So what we are going to do under the root directory, under the artifact, we are going to create a folder called data ingestion. So if I show you the artifact folder, so under the artifact we have our data ingestion folder. Now under the data ingestion, what we are going to do, so this is the source URL that we have, and now here that I'm going to download a data from our central repository called GitHub. So if I show you here, so as you can see here we are going to download, as you can see we have a many sources to get a data, cloud or the database or the central repository called GitHub. So right now here that I have selected a central repository. Okay, so if you want a project related to the cloud or related to a database, make sure guys, please write it down in a comment section. Okay, you need a project related to a database, integration with the database or integration with the cloud. Okay, so that I can come up with some of the more projects related to the cloud or the databases. But right now here I'm going to use a central repository, or we can say a GitHub. Okay, so we are going to extract or we are going to fetch a data from a GitHub repository. So the source URL that I'm going to define a GitHub repository. After that, what we are going to do, so under this particular artifact that we have created a data ingestion folder, and under this particular data ingestion folder that we are going to download our data. So if I show you here, so data ingestion, and here that we are going to download this particular data.zip data from our source URL. Okay, so whatever the data that we are going to download, we are going to store under the data ingestion. After that, we are going to unzip. As you can see, this is the zip file that we have. So we are going to unzip this particular file under our data ingestion folder. So first we are going to create a directory. After creating a directory, that we are going to download the data from this particular source URL. After that, we are going to store under the data ingestion folder, and then we are going to extract our data under our data ingestion. So this is the all the variable that we have, a root directory, source URL, local, and these are the all the values that we have related to this particular variable. Okay, so this is the complete data ingestion object that we have, and under this particular object we have the many variables and the value. Now second that we have the data validation object. Again under this particular data validation object we have a multiple value, we have the multiple variables. Okay, so first root directory. So again we are going to create one directory called data validation under the artifacts. So if I show you, see, yes, under the artifacts we have our data validation directory. Now under this particular data validation directory, what we are going to do, so we are going to copy our this particular data, from this particular mushroom data, that we are going to copy where, we are going to copy under our mushroom. This particular data, what we are going to do, so whatever the data that we have here under our data ingestion, we are going to do the data validation under the data validation directory. Okay, so that's why the first that we are going to define our previous data. Okay, so this is the our previous data that we have. So let me define you in this way. So let's say first that we have the old data. Okay, based upon the old data that we have some of the features, we have some of the feature data type. Okay, now we are going to call here the old data type. After that, whatever the new data that we are getting, so under the status file, as you can see the artifact under the data validation, we are going to create the status.txt file. So under the status.txt file, whenever I receive the new data and we have the old data equal to new data, in this case that we can return true. As let's say we have the old data not equal to new data, in this case that we are going to return or false. Okay, so right now what we are going to do, whatever the old data that we have, the same types of the new data that we are getting. So that's why if I show you the data validation under the status.txt, that we have the validation status equal to true, it means whatever the old data that we have, the same types of the new data that we are getting. So that's why we have the return status called true. So here data validation part is completed. Okay, now after that, here again data transformation object that we are going to create. So first we are going to create a root directory under the artifact. So if I show you again, so yes, we have our data transformation directory, and under the data transformation, from the data transformation that we are going to call our previous data called data validation, so that based upon this particular validated data we can apply a complete data transformation where we can handle the missing value, we can handle outliers, we can handle the imbalance data. Okay, so these are the complete feature engineering and the data pre-processing technique that we can apply whatever the validated data that we have. Always we can apply a data validation over our validated data. Okay, now after data validation, so if I show you here, so as you can see here that we have the data transformation, and in this data transformation that we have the train, test and our original data. Okay, so again under the data transformation, definitely that we can split our data into the training and testing part, right? So that's why here we are going to call our train and test. That's why we have our data train and test. Now we have a model trainer object. Under the model trainer, again that we have the multiple our variables and the value. So first we are going to create a root directory called model trainer. So if I show you here, so yes, model trainer directory that we have. Now we are going to call our train data and the test data. So train data path and the test data path from where? From our data transformation file. So we have under the data transformation, we have our train and test data. Okay, after that, after the model training, based upon this particular data that we are going to apply a multiple machine learning algorithm, and based upon this one that we are going to create our model, and we are going to save our model in a job-lib format. It's totally up to us. We can save into the pickle or into the job-lib format. Okay, now we have the next steps called model evaluation. So again, first of all, we are going to create a directory, model evaluation directory. Now we are going to call our test data. So from data transformation, we are going to call a test data. We are going to call a model path. So under the model trainer that we have the model.joblib. So yes, this is the model that we have, and after that, after the model evaluation that we are going to create a matrix.json file. So if I show you here, so under a model evaluation we have our matrix.json file. So yes, under the matrix that we have our complete accuracy. Okay, so whatever the model accuracy that we are getting, so those accuracy that we have under our model evaluation file. Okay, so this is all about the config.yml file, and under this particular config.yml file we are going to define object, variables as well as a value for our all the pipeline. Okay, and based upon our pipeline that we are going to download the data, or we can say we are going to extract the data from the central repository called GitHub. After that, we are going to validate, we are going to apply the data transformation technique, there we are going to build a model, and then we are going to validate our model. Okay, and based upon the validation that we can select a final model, and then we can put it down in a production. Okay, so this is all about our config.yml file. Now what I can do, let me jump into the project flow. Here we have the config entity. So after writing a code under the config.yml file, we need to jump into our config entity file. So this is the src folder that we have. Here we have a mushroom project, and here we have the entity file. Under the entity that we have our complete config entity.py file. So let me open. Now let's try to understand this particular complete code. So first of all, what we are going to do, we are going to import a data class, as well as from the path lib we are going to import a path. Okay, after that we are going to create a multiple classes for our all the pipeline. So class data ingestion config pipeline, data validation config pipeline, data transformation config pipeline, model trainer config pipeline, and the model evaluation config pipeline. So all the class that we are going to create. Now under this particular class we are going to define all the variables, whatever the variables that we have under our config.yml file. So as you can see here that we have the 4 variable: root directory, source, local, and the unzip. So here we are going to call local directory, so the directory that we have in a path format. So yes, the path. After that we are going to define our source URL in a string format, because we have the link, and the link that we have always in a string format. Now local data file path, so again the file that we have, so path, and we are going to store under the directory, so we have the path. Okay, now same for the data validation. So root directory that we have, the again directory that we have in a path format, so we have a path. It means directory. So this is some of the path that we have. So if I show you here, so if I copy this particular complete path from here, that I will go and copy the path. Okay, not here. So let me go under the data ingestion, as we are talking about the data ingestion. So root directory. So if I open and control right click, copy, and if I paste here, so as you can see, this is the complete path that we have, a data ingestion. This is the complete path that we have, right? So that's why here we are going to call a root directory called a path. Source URL, so URL that we have in string format. Local data file again that we have in a path format, because we are going to store here, and we are going to store under the directory, so that's why we are going to call a path. Okay, next that we have the data validation config. So first again root directory that we are going to call, because we are going to create a directory. So first one is a path. Status file, so again the file that we have in a string format, and these are the complete our directory that we have. So directory that we are going to call a path. Now that we have the schema, so if I show you here under the schema.yml file, so under the schema.yml file we have our complete data, we have our complete features, a column. These are the complete features that we have, and along with the features we have our complete data type for our all the features. Okay, apart from this one we have our target column as well. So we are going to call here our schema file, all the schema and the schema that we have in a dictionary. Okay, now based upon this particular data that we need to do the data validation. Okay, so we have a ABC or the XYZ column or the features in a numerical data type, or the object data type, or the date type format. Okay, so based upon this one that we are going to do the data validation here. So that's why we are going to call our schema. Now we have a data transformation. So again that we are going to call the directory, and after that we are going to save our train test as per after the data transformation. So again we are going to define here a path. Now we have a model training. So root directory, train data, test data, model name, and the in estimator, main sample split, and the target column. So these are the parameter that we are going to define under our machine learning algorithm. So whatever the machine learning algorithm that we are going to create, first of all we can create the object, and under the object that we can define some of the parameter called n estimator, main sample split, and so on, that we can define a multiple parameters. As well as we are going to call a target column, because based upon the target column that we can divide our data into the dependent and independent data, and then we can train a machine learning algorithms. After that we are going to do the complete evaluation. So model evaluation config, root directory, based upon the test data. So we are going to call test data, model file path. So this is the ABC or the XYZ model that we have under our model trainer directory. All the parameters that we are going to call, and parameter that we have always in a dictionary format. Matrix path that we are going to call a target column, and MLFLOW URI. So again the MLFLOW URI, so that we can store our all the, we can track our each and everything, all the information under our MLFLOW. Okay, so that's why here we are going to call the MLFLOW URI as well. Okay, so this is all about our config entity, where we are going to create a multiple class based upon our pipeline, like data ingestion, data validation, transformation, model training, model evaluation. Okay, and based upon this one, that we are going to define our all the config file values. Okay, all the config file variable. Okay, now we are able to understand our config.entity. Now next that we have the constant, and under the constant that we create a variables related to our pipeline. Okay, so under the constant we always create a variables related to our pipeline. So this is the constant folder that we have. Here we have our underscore init.py file. So let's open. Now in this particular constant file, what we are going to do, first of all we are going to call our path. After a path, that we are going to call our config.yml file. So whatever the config.yml file that we have here, so this particular config.yml file, we are going to call schema file. So schema.yml file. So here we have a schema.yml file, and we have our params.yml file. So if I show you here, so as you can see, this is the complete parameter that we have. So whatever the machine learning algorithm that we are going to use, so here we are going to use a random forest. So these are the complete parameter that we have. So same thing that we are going to call under our constant file. So if I show you here, so yes, this is the complete constant file that we have. Apart from this one, we have a second way as well. So if I talk about the little bit about the second page, so in a second page, what we can do, whatever the variable we have under the config.yml file, what we can do, so for our all the variables like root directory, source directory, source URL, local data file, unzip directory, so for all the variables, what we can do here, we can create a constant variable for our all the pipeline, like data ingestion or data validation. So first, constant variable related to data ingestion, okay, for our all pipeline. Same way that we can create for data validation. So here that we can say a data validation. After that we can create a variable for model trainer, okay, and so on for our all the pipeline. In my upcoming machine learning projects, I will show you in a different way. Okay, so this is the first way that we have to build an entire project pipeline, and in our upcoming project that I will show you in a some different manner, where we can create a multiple class, a multiple functions, and under the constant file again that we can create a multiple variables like this one. Okay, so this is the first way that we have, where we can call the all the path related to our all the YML file. Okay, now after that, now with the help of this particular config.yml, params.yml, and the schema.yml, we are able to call all the data, all the information, whatever the information we have under our params.yml or under our schema.yml or under our config.yml file. So with the help of this particular path, that we are able to call our all the information, whatever the information that we have under this particular file. Okay, now after that, after writing a code under the constant file, next that we have the configuration file. So what I can do, let me open our configuration file. So here we have our configuration file under our config folder. So now let's try to understand this particular complete code. So what we are going to do, let me do in this case. First of all, we are going to import our all the important library. So as you can see from the mushroom constant file, we are going to import each and everything. Now we need some of the helper function as well. So read YML and create a directories YML function, helper function that we need. Okay, so what I can do, let's first of all try to talk about our helper function, then we can jump into this particular file. So let me go under our utils folder. So yes, we have our utils folder here, and under the utils folder we have our common.py file. So let's talk about first of all our all the helper function, whatever the helper function that we have in this particular common.py file. So first of all, again that we are going to import our all the important library, whatever the important library that we have, like OS, YML, from the mushroom project that we are going to import a logger. Okay, now we are going to call a job lib, JSON, path. Okay, so these are the complete library that we are going to import. After that, a first function that we are going to define. So define a function to create a directory. So we are going to define a function to create a directory if the directories are not available. So right now, as you can see that I have run this particular project, so that's why I have this particular artifact directory. If I show you my log here, so let me show you the log. So this is the log directory that we have, and under this particular log directory we have this particular complete log. So as you can see, data ingestion, stage started, YML file, calling the YML file, loaded a params.yml, schema.yml file loaded, create directory, so directory created, artifact, under the artifact data ingestion directory created, store directory, and the so on. This is the complete log that we have for our data validation stage started, data transformation stage started. After that we have our model trainer stage, model evaluation stage. Okay, so on we have our complete pipeline logs here. Okay, so what we are going to do, the right now we did not have, because I have run this particular, that's why I have the artifact, but in your cases you did not have this particular artifact, right? So we need to create this particular directory, our artifact directory. Till now whatever the config file that we have created, so this is the variable that we have created, artifact variable, but we need a directory so that we can store our all the outputs. So that's why here we are going to create a function to create a directory. So create a directory where we are going to define our path directory, so path to the directory list, and the for was equal to true in a boolean. Okay, so here again that I have mentioned in a detail, so create a list of the directory. Okay, argument we are going to path a directory, so list of the path of the directory, and ignore, so ignore log, so ignore if the multiple directory is to be created, and default that we are going to set a false. Okay, so with the help of this particular function we are going to create a directory, whatever the directory that I need to store my output. Okay, to store a output, that's why we are going to create a directory here. Okay, now a for loop that we have, so for path in a path directory, so from here directory that we are going to call, and after that we are going to create a directory if exists, in this case that we are going to skip the directory. Okay, if for was logger, so created a directory at in this particular path, so this is the directory that we are going to create. Okay, so with the help of this particular function we are going to create a directory. Now directory demo, so next function that we have a directory demo, so directory path again that we are going to call a list of the directory, again we are going to create a directory here with the help of directory demo function. Okay, now we have the read YML, so look like the I'm going to repeat this particular directory, so even in this case you can just comment this particular code, because the same function that we are going to call here. Okay, so both the function that we have the same, only the function name that we have a different, but the work by same function, like both the function work same. Okay, so in this case you can just remove this particular function, this is fine. Okay, now after creation of our directory, our output directory, what we are going to do, so next function we are going to create to read our YML file. We have the multiple YML file, config.yml, schema.yml, params.yml, right? So what we are going to do, now we are going to read our YML file, so that's why we are going to create a function to read our YML path to YML. So this is the path that we are going to define, and it will return as a config box all the information. Okay, so read YML file and returns all the information, whatever the information that we have under our YML file. Okay, now argument by, so we are going to pass the input data. Okay, so we need to read our config.yml or schema.yml or the params.yml. Okay, now here we are going to write our complete try and the except block. So yes, this is the complete try and the except block that we have. So what I can do, let me put it down in the next line, this one. Okay, so here that we have the try and the except block. So try, first of all we are going to open our YML file, so open path.yml. so whatever the YML file that I want to read the data, first we can open the file. After that we can load the content. So here yml.safe load, we are going to load our content, complete content, and then we are going to return our complete logger. So okay, so the YML file is loaded successfully, and we are able to read our all the contents, whatever the contents that we have under our YML file, like config.yml or the schema.yml or the params.yml. Okay, so this particular function, it will help us to read our YML file data. Now after that, here the next function that we have a save a JSON file. So if I show you our artifact, so under the artifact we have our model evaluation file, and here we are going to create a matrix.json. Okay, so that's why we are going to create a function to define a function to save the JSON. So this is the function that we are going to create. So save JSON data. So under the JSON file we are going to save a JSON data. Okay, argument that we are going to path to the JSON file, and data to be saved in a JSON file. So first we are going to open our JSON data, and then we are going to write w, it means that we are going to write. After that we are going to dump our complete data. So json.dump, and we are going to dump our complete data. So this particular function, it will help us to write something under our JSON file. Okay, now after that, next function that we have the load JSON, because next that we need to validate our model. So to validate our model, that we need to load our JSON information, whatever the JSON information that we have. So that's why we are going to write a function to load a JSON file. So load a JSON file data argument that we are going to pass here path to the JSON file, and then it will return all the information in a dictionary format, whatever the information that we have under our JSON file. So if I show you this particular file, so yes, as you can see here in this particular matrix.json file, we have the accuracy in a JSON format. Now we are going to return this particular matrix JSON information in a dictionary format. So with the help of this particular function, that we can load our JSON information in a dictionary format. Okay, after that we are going to save a binary data. So binary data, it means like whatever the, like after the data pre-processing, whatever the data or the output that I want to save in a binary, in this case that we can use this particular save binary function. So save binary file, so we are going to define a function save bin. Okay, and the data that we are going to pass argument data to be saved as a binary, and the path that we are going to define a directory, our binary file directory. Okay, so this particular function, it will help us to save a binary data. Okay, after that we are going to load. So let's say if we want to load our binary data, in this case this particular function that we can use. So define a function to load our binary data, where we are going to pass argument a path to the binary file, and it will return the object stored in the file, whatever the information or the object information that we have under the binary file. So it will return the complete object file data. So first that we can load the data, and then we can pass our data. Okay, so this particular binary data that we are going to load. After that, here the next function that we have a get size. So let's say if we want to check the size of our model, in this case that we can use this particular function. So get the size in the KB. So this is the function that we have, get the size in the KB, where we are going to define a path as a variable, and after that the size that we have for this particular function, the return statement that we have a size in a KB. Okay, so with the help of this particular function, what we can do, we can save a data in a KB format. Okay, so that's why here we are going to divide into the 1024, so that we can save into the KB format. Okay, so these are the some of the helper function that we have, and with the help of this particular helper function, that we can save a pickle file, a joblib file, we can load our YML file, we can save a binary data. Okay, so many more function that we have created, and with the help of this particular function, whenever I need to save a JSON data, or whenever I need to save a binary data, we can just call this particular function. No need to write same code, same function again and again, and this is called a modularity. Okay, a modular coding. Okay, now we are able to understand about all the helper function, whatever the helper function, whatever the required helper function we have. Okay, now let me open the project flow. So after writing here, we need to again go back under the configuration.py file. So let's try to understand this particular file, and then we can jump into the data ingestion. So yes, we have our config folder, here we have our configuration.py file. Let's try to understand. So now we are going to import a two helper function, read YML and the create directory. Right now I need a two helper function, read YML and create a directory. From where? From our helper function file, from our utils folder. Apart from this one, that we are going to import our all the classes. So if I show you in this way, so from our entity folder, we are going to import our all classes like data ingestion config, data validation config, transformation, model trainer, and so on, our all classes that we are going to import. Now we are going to create a class. So class configuration manager class. Here we have a function, so define underscore init underscore dot py underscore. This is the complete constructor that we are going to define. Okay, where the by default argument that we have the self. After that we are going to call our all the path like config file path, params file path, a schema file path, and this particular file path that we are going to call from where? From our constant file. So if I show you here, so yes, this is the variable that we have created, and all the variables that we are going to call under our config.yml file, so that we can read all the information, whatever the config.yml or the params.yml or the schema.yml information that we have. Okay, so that's why we are going to pass as an argument, and after that we are going to use a helper function called read YML helper function, and with the help of this particular helper function we are going to read our all the YML file, config YML, params as well as schema.yml, and then we are going to create a directory, so the artifact root directory that we are going to create. So for this one again we are going to define a function here, a create directory helper function. Okay, now after that here we have a function called first function, as we are running our first pipeline. So data ingestion, define a function to get a data ingestion config. So data ingestion config equal to self.config a data ingestion, again that we are going to call our directory. So create directory because we need a directory to store our data ingestion output. Okay, now after that we are going to call a variable data ingestion config, where we are going to call a class, and whatever the class parameter that we have. So if I show you here, so in this particular class that we have the 4 parameter: root directory, source, local file, and the unzip. So we are going to call all the parameter root directory, so config.root directory, source URL, config.source URL, local data file path, so config.local data file path, unzip directory, so config.unzip directory. Okay, so all the variables we are going to call from our this particular config.entity file related to our data ingestion. Okay, and after that we are going to return our data ingestion config. So this is related to our first pipeline. So on for our all the pipeline for our data validation, transformation, model training, model validation, and the model evaluation. Let's try to understand the next pipeline. So next pipeline that we have the function, define a function to get a data validation config. Data validation, it is going to return a data validation config. Again we are going to call the data validation and the column status, so column, and we are going to create a directory called data validation directory, and after that again based upon this particular file, this particular parameter, we are going to call all the parameters, all the values again. So data validation config, we are going to call a data validation config, and after that we have the root directory, status file, unzip directory, all the schema. Okay, then we are going to return a data validation config. After that the next function that we have, a define a function to get a data transformation config. We are going to return a data transformation config. Calling a data transformation, we are going to create a directory, and then again based upon this particular config entity we are going to call both the variable called root directory and the data path. So if I show you again, so yes, here that we have our root directory and the data path, and we are going to return our data transformation config. Okay, we are here at the end in a configuration.py file that we are going to join our entire path, okay, and entire files and the entire variables. Now next function that we have a model trainer, again this is going to return a model trainer config for all the variables. So model trainer, random forest, and the target column that we are going to call. We are going to create a directory called model trainer, and then we are going to call a config for our all the parameters based upon this particular model trainer config: root directory, train data, test data, model, estimator, and each and everything that we are going to call here. Okay, now from the schema, as you can see that we are going to call the name, from the parameters that we are going to call the mean simple split, and this is the argument that we have, right? So that's why we are going to call the parameter. So if I show you here, so yes, that we have the params.yml file, and here that we have our board the estimator. So that's why from here, from this particular file that we are going to call, so params, from the params in estimator and the mean simple, and from the schema that we are going to call our target column, and then we are going to return this one. Next function we have a define a function to get the model evaluation config. A parameter we are going to pass a self by default parameter, and this particular function, this is going to return a model evaluation config. Now config, params, and the schema one by one that we are going to call. So from our config file that we are going to call the model evaluation, from the parameters that we are going to call the random forest. So if I show you here, so here we have a parameter, and this particular random forest parameter that we are going to call, and from our schema file we are going to call our target column. So if I show you our schema file, so here, and we have our target column here. Okay, so this particular complete config, params, and the schema file we are going to call. After that we are going to create a directory if the directory is not available, and then we are going to create a variable called model evaluation config. We are going to call a model evaluation config the return statement, and after that here we have our all the entities. So root directory, test data path, model path, all parameters, matrix, target column, and MLFLOW URI where we can store our complete information. Okay, so if I show you our entity file, so from here, as you can see here we have our model evaluation config, and from here we are calling root directory, test data path, model path, all parameters, matrix, target column, and the MLFLOW URI. So one by one we are going to pass all the parameters under our model evaluation config, and at the end that we are going to return a model evaluation config. Okay, so this is all about the configuration related to our all pipeline like data ingestion, data validation, data transformation, model training and model evaluation. Now let me jump into our pipeline files. So here we have a pipeline flow.txt. So till a utils file that we are able to complete. Now next that we have a data ingestion pipeline. Now as for the pipeline, first that we are going to perform a data ingestion. So here we have our SRC folder, and under the SRC we have a mushroom project folder, and under the components we have our data ingestion.py pipeline. So this is the first data ingestion pipeline step that we have. Now in a data ingestion steps, what we are going to do, so we are going to fetch a data from different sources, from cloud platform like AWS or the Azure or the GCP, or we can fetch a data from a databases, or we can fetch a data from central repository called GitHub. So here, as we all know, we are going to fetch a data from central repository. As you can see here that I have mentioned a source URL called a GitHub, right? So we are going to fetch a data from central repository from the GitHub platform, right? Now what we are going to do in a data ingestion, first of all we are going to import our all the important libraries. So here we have a OS. From the path lib we are going to import path, import URL lib.request. So here that we are going to import request, a zip file, because whatever the data that we have over the GitHub, as you can see this is the zip file data that we have. So that's why we are going to import a zip file as well. Now from the mushroom project we are going to import a logger, and from the utils file we are going to import a get size helper function. Okay, and apart from this one, from our mushroom project, from our config entity file we are going to import a data ingestion config. Okay, so these are the some of the important library that we are going to import. After that we have created a class, a data ingestion class. Now we are going to create a complete constructor. So define underscore underscore init underscore underscore, where we are going to pass a parameter. So self, this is the by default parameter that we have. Now after that we are going to call a config. So data ingestion config that we are going to call. Now here we are going to define our config. Okay, now we are going to create a two function in this particular data ingestion.py file under data ingestion class. Okay, so the first function that we are going to create here, a download file, because first of all that we need to fetch a data from central repository called GitHub. So that's why the first function that we have, a download data, argument wise that we are going to pass a self, a by default argument. Now after that we are going to write if else condition here. So if not os.path.exist, so if our local data file, so if I show you this particular directory, so under the config entity, so as you can see the local data file directory that we have, and if I show you here under the config.yml file, so here we have our directory called data ingestion. So first of all that we are going to check, okay, so this particular directory, this particular data ingestion directory, artifact slash a data ingestion directory is exist or not. Okay, so that's why here we are going to write a condition. So if not os.path.exist, so let's say if this particular path is not exist, so self dot which path, our local data file path, then we are going to call a file name and header. After that we are going to call our request library, request dot URL retrieve function that we are going to call, and with the help of this particular URL retrieve function we are going to download a data from our central repository. So we are going to pass URL, so self.config.source URL, so the source URL that we have our dataset link that we have. So we are going to download the data. So first we are going to define our URL, and after that where we want to store, so we want to store our data under local data file directory under our data ingestion directory. So that's why we are going to pass a two parameter, first the URL where we want to download the data, second a file name in which location we want to save our data, and after that this is the logger that we are going to capture. So okay, so the file downloaded with the following information where we will get our complete headers. Now if I show you the log, so here we have our complete log, and here we are calling, as you can see, the data ingestion, and after that a complete log that we are getting. So data ingestion in this particular data .zip file downloaded with the following information. The following information, it means these are the complete following information that we are going to capture it. Okay, so that's why here this is the logger that we are going to capture. So logger.info, a downloaded file with the following information. Okay, else file already exists of the size. So whatever the file that we are going to download, this particular file is already exists in our project directory. Okay, now after that, next function that we have, now we are able to download our file. Now we have our file in our local file. So after downloading, what we want to do, we want to extract, because whatever the file that we have downloaded, right now those files that we have in a zip format. Now we want to extract those files so that we can perform some of the operation, we can find out some of the insights over our data. Okay, so that's why the second function that we are going to define here. So extract the zip file, whatever the zip file that we have downloaded from our GitHub repository. So the second function that we have, extract zip file, where we are going to pass argument called self. So this particular zip file path that we have in a string format. Now extract the zip file into the data directory, whatever the data directory that we are going to define. Okay, so unzip path variable that we are going to define, and we are going to call the unzip directory. So if I show you, this is the unzip directory that we are calling from here. This particular unzip directory we are calling. Okay, now after that we are going to create a folder. So okay, so if the folder is not created, in this case try to create a folder. So os.make directory unzip path. So we are going to define the unzip path, and if the directory exists, in this case that we can skip this particular point. Okay, now after that what we are going to do, so we are going to extract our complete data zip file. So with zip file.zip file, we are going to pass a local file directory, a read mode, a zip file, and then we are going to use extract all function, where we are going to pass our complete zip file data path. Okay, so with the help of this particular function, we are going to extract our data zip file. Okay, so now we have a data in a zip format, even we are able to extract our data. So if I show you our artifact, so here as you can see under the data ingestion, we have our data.zip file, and after extracting that we have our data in a mushroom.csv file format. Okay, now after understanding a complete data ingestion part, so now we have our complete data in a zip format as well as in a CSV format. So now we have our complete data. Now what we can do, we can perform a second operation called data validation. So what I'm going to do, now here I'm going to perform this particular operation, a data validation. This particular pipeline and the test file we can understand later, and parallelly that we can execute. Now let's try to understand a data validation, data transformation, model training, and so on, our all the pipeline. Okay, so now we have our complete data in our artifact directory, even we are able to extract our data into the CSV format. Now next pipeline that we have are data validation. So now what we are going to do in a data validation, again first of all we are going to import our all the important library like pandas. We are going to import a logger, and from a config entity we are going to import a data validation config file. Okay, now after that what we are going to do, so here we are going to create a class, a data validation class. We are going to define a constructor, so define underscore init underscore self, a by default argument, and the data validation config that we are going to call here. Now we are going to create a function, so define a function to validate all the columns. As I mentioned, we need to validate our column name, we need to validate our column data types. Okay, so those things that we are going to do the validation here. So first a function that we are going to create, so define a function to validate all the columns, and this particular validation it returns a boolean value, a true or false. So if successfully verify validated, in this case that we will get the response as a true, else we will get a false. Okay, now try and the except block that we are going to call, and under this particular try and except block we are going to write our complete code. So first a validation status equal to none, because right now that we are able to fetch a data only. Now we are going to perform a data validation. So right now in initial steps that we are going to set a variable validation status equal to none. Right now we don't know our data is validated or not, so that's why we are going to set here none. Now we are going to read our data, so data equal to pd.read csv, because first of all that we need a data. based upon the data, then we can perform a data validation steps, right? So we are going to read our data. So pd dot read underscore csv a self dot config, and from here that we are going to call unzip data directory. Okay, now from here that we are going to call a data dot column, so list of the columns that we will get. Okay, so how many columns that we have in our data. From where that we are going to call our all the schema, so self dot a config all the schema key. So if I show you this particular all the schema key, so here that we have all the schema key that we have in a dictionary format. Okay, so we are going to call our data schema here, so in a key format, so we will get our all the schema key value. Okay, key mainly that we will get, and after that we are going to write our complete for loop. So for all the columns we are going to iterate one by one all columns. So for column in all the columns, if column not in all the columns, in this case that we can write, okay, so validation status false. Just try to understand this one. This is the very important concept that we have. Okay, because in an industry on the monthly basis or on the quarterly basis, we are getting a data from our client. Now every time whenever we receive a data from our client, after extracting or after fetching a data from different sources, we need to do the data validation so that we can verify, okay, so based upon whatever the data that I have used during the training purpose, the same types of the data that I received right now. Okay, so that's why if column not in all the column, all the schemas, it means this particular file schema.yml file, under this particular schema.yml file we have our all the columns along with the data type. So that's why we are going to call here column, if column not in our all schema, then return a validation status equal to false. With open, we are going to open the file, a status file, and then we are going to write a validation status equal to what? Validation status equal to false. So if I show you here, so as you can see, this is the data validation file that we have, and here that we have the mushroom.csv, and here that we have the status file, status.txt. So in this particular status.txt file, that we are going to write our complete validation status. Okay, so validation equal to true or false, else validation status equal to true, and again that we are going to open our file and then we are going to write, okay, so now our data validation status is true because the same types of the data that I received from our client. Okay, now after that, after data validation, now what we are going to do, so we are going to drop the null value columns and the unuseful columns. So yes, we are going to call a data drop function, and here we are going to define our column name called valid type and stock root. Okay, and access equal to 1, it means that we are going to check the column wise, and after that we are going to drop our unnecessary, or we can say unuseful columns, and then we are going to save a data into the mushroom.csv name. Okay, so as you can see, this is after the data validation, and after dropping these two columns, then we are going to save our data into the mushroom.csv format. Okay, so yes, and after that we are going to return a data validation status where under our data validation directory. So if I show you this one, so as you can see right now whatever the data that we have, so the same types of the data that we are getting a second time, that's why the data validation status equal to true that we have. Okay, so yes, this is the complete data validation that we have. So right now here we are going to validate only the data columns name. Okay, but in a real time scenario that we can validate many things. Okay, depends upon our data, depends upon our features. Okay, so we can validate our complete columns name, we can validate a columns types, we can validate a different our complete column number, we can validate a complete file name, a column name. So these are the things that we can validate during the data validation. Okay, so now we are able to validate our data. Now after data validation, next step that we have to perform a data transformation where we can handle a complete feature engineering. So yes, this is a data transformation.py file that we have. Now let's try to understand this particular file. So again, first of all, we are going to import our all the important library like OS from the mushroom project, a logger from the sklearn.preprocessing, that we are going to import a level encoder so that whatever the categorical data that we have, that we can convert into the numerical column. Okay, so from sklearn.model selection we are going to import a train test split, from the pandas that we are going to import a PD, and from the config entity that we are going to import a transformation, data transformation config. After that, a class that we have created, so class, a data transformation class, we are going to create a complete constructor. So define underscore underscore init underscore underscore where we are going to pass a data transformation config. After that, we have created a complete function here. So label encoding, as you can see here that I mentioned, I'm only adding the train test split because this data is already cleaned up. Okay, so our data is already clean, so that's why we are not going to perform some other types of the like the operation of feature engineering operation, like the missing value handling or the outliers handling or the imbalance data handling. Okay, but let's say if in your data, if you have a missing value, if you have a outliers, if you have a imbalance data, in this case you need to create a function. Okay, so right now in this particular data we did not have the our missing value as well as the outliers. Our data is totally cleaned, so that's why I'm not going to perform those operations. But in our upcoming project, definitely I will add those functions, so that if required in your upcoming projects, or if you are doing any personal projects or the organization project, in this case you can take a reference from my upcoming projects. Okay, so now let's proceed. So here we are going to create a function to define a function to do the label encoding to our all the features. Okay, now we are going to read the data, because first of all that we need a data, and then we need to perform a encoding technique. Right now here we are going to capture the logs. So logger.info, converting all the categorical column into the numerical using the label encoding method. Okay, so we are going to create object, label encoder object. After that we are going to write a for loop. So for from this particular data columns we are going to iterate one by one all the columns, and after that we are going to apply a label encoder, and then we are going to apply a fit transform on our column, on our all the categorical column. Okay, so now after applying this particular for loop, now a column data type after converting into the numerical features, so whatever the categorical data that we have, so we are going to use a label encoder, and with the help of label encoder we are going to convert our all the categorical data into the numerical format. Okay, and after that we are going to save into the root directory called data.csv. So after converting our complete label encoding technique, then we are going to save into the data.csv. So if I show you our artifact file, so yes, this is the our artifact folder that we have. Here we have a data transformation, and now as you can see that data.csv. So after applying a label encoder technique, then we are going to save our data into the data.csv format. Okay, so this is the first function that we have, and with the help of this particular function, whatever the categorical data that we have, we are going to convert our categorical data into the numerical format. Okay, now after that the second function that we have, so define a function to train test splitting. So here we are going to split our data into the train and test. We are going to call a self by default parameter. Now we are going to read a data, so pd.readcsv, and we are going to read a data, which one? Our clean data, our data.csv from this particular directory. Okay, now after that whatever this particular data that we have, so now we are going to split this particular data into the train and test. Okay, so train and test split function that we are going to call. So 75% of the data we are going to use for the training purpose, and 25% of the data we are going to use for the testing purpose. Okay, so 20% of the data that we are going to use for the testing purpose, and 80% of the data we are going to use for the training purpose. It's totally up to us. We can divide us like 80-20 or 75-25. So in this way that we can divide our complete data, or 70-30. Okay, now after dividing our complete data, so after applying a train test split, then we are going to save our data into the train.csv and into the test.csv. So as you can see here we have our test.csv, and here we have our train.csv under our root directory. Okay, and after that here we are going to check the shape of our complete data. So in a data transformation, what we are going to do, so first function, whatever the categorical data that we are going to convert into the numerical data. Second, that we are going to split our data into the train and test. Okay, so yes, this is all about our data transformation. Now we have our complete train and test data. Now what we can do, now we can apply a model. So next that we have a next pipeline that we have the model trainer. So let me open this particular file. Here what we are going to do in a model trainer, first of all we are going to import our all the important library. Again, from sklearn data preprocessing we are going to import a label encoder. From the ensemble sklearn.ensemble we are going to import a random forest classifier, a numpy, pandas, joblib, okay, and the model trainer config that we are going to import our all the important library. Now here we are going to create a class, so model trainer class that we are going to create. After that we are going to create a function, so define a function to train our machine learning algorithm. So here algorithms by where we are going to use a random forest, but in your case you can use a multiple machine learning algorithm. You can do the hyperparameter tunings and then select a final model. Okay, so what we are going to do, so again we are going to create a function. So define a function to train a machine learning model. Now we are going to read our train data as well as the test data from our artifact directory. So train data file, data path and the test data path. So we are going to read our train as well as a test data we are going to read. After that we are going to define our complete data, x train, x test, y train and y test. So x train underscore data dot drop. So here we are going to drop our target column. Again from the x test data we are going to drop our target data, and in a train y and in a test y that we are going to select our target column. So we are going to divide our complete data into the dependent and independent features. Okay, dependent and independent features. After that we are going to apply a random forest algorithm. So rf equal to random forest classifier, where we are going to apply some of the parameter. So if I show you here, so here we have a params.yml. So here in this params.yml we have a random forest algorithm and we are going to call a two parameter. It's totally up to us. We can define a multiple parameter, okay, but right now that I'm going to take only two parameters so that we can train our machine learning algorithms easily. Okay, but in your case if you want you can add some more parameter and then you can do the training. So n estimator 100 and the mean sample split that we are going to define a 2. Okay, now if I go back again under the model trainer, so we are going to create a variable called rf, a random forest classifier, where we are going to define n estimator. So self.config.n estimator and the mean sample split that we are going to call. After that a random state that we are going to call a 42. So these are the some of the parameter that we are going to call. After that we are going to fit our model over the train x and the train y data. So we are going to fit our complete model and then we are going to dump our model into the joblib format. So joblib.dump, so we are going to dump our random forest model os.path.join. So in this particular location we are going to join and we are going to save our complete model, a random forest model. So if I show you our model trainer directory, so here we have a model trainer directory and here we have our model joblib file. Okay, so this is the model that we have. So in this way that we can train our complete machine learning algorithm. So right now that I have used only one machine learning algorithms, but in your case if you want you can just define a multiple machine learning algorithms. Okay, so now we are able to complete a model training. Now after that next that we have the model evaluation. So here that we have the model evaluation. So let me open this particular model evaluation file. So yes, this is the model evaluation file that we have. Now what we are going to do in this particular model evaluation, again first of all we are going to import some of the important library. So again OS from the path lib we are going to import a path logger, matrix by that we are going to import accuracy score, a confusion matrix, and from the URL lib parse that we are going to import URL parse, MLFLOW, because as I mentioned we are going to integrate this particular project with the MLFLOW as well. So that's why we are going to import MLFLOW. So MLFLOW.scalan, numpy, panda, joblib, and these are the config that we are going to call a class. So model evaluation config, and this is the helper function that we have. Okay, now after that we are going to create a class, a model evaluation class. We have created a complete constructor where we are going to pass a model evaluation config. Now we have our function. So define a function to evaluate a matrix where we are going to pass a self by default parameter, actual data, and the prediction data that we are going to pass, a prediction actual output and the predicted output. Okay, now here we have our accuracy. So accuracy score, actual comma predicted, so the data that we are going to pass, and this is the logger information that we have. So the accuracy is we are going to check our complete accuracy in a logger file. Okay, now after that we are going to check the confusion matrix as well. So here that we will get our complete confusion matrix and then we are going to return accuracy. Okay, so with the help of this particular function that we will get our complete accuracy as well as a confusion matrix for our model. So this is the first function that we have. With the help of this particular first function we are going to check the accuracy as well as a confusion matrix. Now a second function that we have, so define a function to log into the MLFLOW. So whatever the logs that we have, now we are going to store over the MLFLOW. Okay, so now as you can see here we are going to capture the log first of all. So logging data to the DAG sub, but no, I'm not going to use a DAG sub here, that I'm going to use MLFLOW. Okay, now after that a test data, so pd dot read underscore csv. So we are going to read our test data set, so test data path. Now we are going to load our complete model, so load a joblib file. Now xtest and the ytest, so again from the xtest data we are going to drop our target column, and from the y that we are going to select our target column only. Okay, now after that we are going to set the model registry URI. So here we are going to set our complete model registry URI, where we have a self.mlflow URI. So if I show you our config file, so here that we have our configuration file, and from here as you can see this is the MLFlow URI that we have. Okay, so this is the MLFlow URI that we have. So this is the MLFlow URI that we are going to call here under the MLFlow. Okay, so yes, this is the MLFlow that we have. Model evaluation, so yes, model registry, set the model registry URI, and here we are going to call our MLFlow URI. Okay, now after that tracking URL type stored, so we are going to store our all the information, all the schema information under our MLFlow. After that we are going to run a MLFlow, so with MLFlow, so this is the breathe function that we have. So with the help of breathe function that we can start our MLFlow. So with MLFlow dot start run, and then after that we are going to call the predicted qualities, so model dot predict xtest. Now we are going to call the evaluation matrix, so accuracy equal to self dot evaluation matrix. We are going to pass xtest data as well as a predicted qualities output. Okay, now we are going to save the matrix as a local, so whatever the matrix that we have, we are going to save into the local file, and then we are going to log the parameters as well as accuracy. So whatever the parameter that we are going to use, so we are going to log a complete parameters over the MLFlow, as well as we are going to log the our matrix, our accuracy as well. I will show you later whenever we execute and whenever we run this particular project. I will show you over the MLFlow UI as well. Okay, now after that here we are going to set the model registry does not works with the file store, so tracking URL type store not equal to the file. In this case that we are getting this particular. Okay, so the MLFlow dot sklearn log the model, so we are going to log our complete model, so the model name that we have the random forest. Okay, and after that else MLFlow sklearn dot model, so model name that we are getting. So yes, this is the complete function that we have, and with the help of this particular function that we are going to log our complete parameter, matrix, the model. So these are the things that we are going to log over the MLFlow. Okay, apart from this one, with the help of our first function that we are going to evaluate our complete model, where we are going to check the accuracy as well as a confusion matrix. Okay, so yes, this is all about our complete pipeline, where we have a data ingestion, data transformation, data validation, model training, and the model evaluation. Apart from this one, that we are able to integrate with the MLFlow. Okay, now after the model training, if I show you the output here, so as you can see here that we have the model evaluation, and under the model evaluation that we have the matrix.json, and under this one that we have the our accuracy is a 100% that we have over our model. Okay, now what we are going to do, so I'm going to show you our pipeline. So this is the pipeline folder that we have, and under this particular pipeline, because at the end whatever the pipeline that we have created, we need to test this particular pipeline every time whenever we want to execute the data ingestion or the validation or the transformation or the model training or the model evaluation every time. So what I have done here, so as you can see here that I have a pipeline folder, and under the pipeline that we have our all the stages file, a data ingestion file, data validation file, data transformation file, model trainer, and the model evaluation. I have created all the files, so that whenever you want to execute the data ingestion, just run the data ingestion file. Whenever you want to execute a data validation pipeline, just execute the data validation, and so on for our all the pipeline. Okay, so here we have our data ingestion file. Now here what we are going to do, first of all we are going to import our all the important library. Now we are going to call the stages, so stage called data ingestion stage. We are going to create a class, so data ingestion pipeline. As I mentioned, we are going to run our first pipeline called data ingestion. Okay, now we have a class, so define a function to main class, and we are going to call a configuration manager from our this particular configuration.py file. After that we are going to call a get data ingestion function. So if I show you, so yes, this is the function that we have, so they get data ingestion function that we are going to call from our configuration.py file. Okay, and after that we are going to call a data ingestion class from our data ingestion.py file, and then we are going to download the data, and after that we are going to extract the data. Okay, so these are the complete function that we are going to call under the main function, and then here we have the entry point, and with the help of this particular entry point that we are going to run our data ingestion pipeline steps. Okay, Now after that we can jump into the second pipeline called data validation. So yes, data validation that we have the same way that we are going to call first of all the configuration. First of all we are going to import the library, we are going to define the stages, we are going to create the class, a data validation pipeline class, then configuration manager that we are going to define, a function that we are going to call, a next function from our configuration.py file, data validation that we are going to call, and after that a function that we are going to call our validate column data, validate all the columns function from our data validation from this particular file. Okay, now we have our entry point and then we are going to run our data validation pipeline. Okay, same we have for our data transformation. So let's open again, same thing that we are going to call here. So yes, here we have as you can see, first we are going to check the status. So okay, so a status, a data validation status. Okay, so our data validation status that we have the successfully done or not. Okay, so true or false, so we are going to check the data validation status, and based upon this one, so if status equal to true, in this case that we are going to perform a data transformation steps. Again here we are going to call the configuration manager, we are going to call a get data transformation config, a transformation level encoding, all the encoding function, and then we are going to train test split. So we are going to split our data. Okay, now here we are going to call the entry point, and with the help of entry point that we are going to run our data transformation config. Okay, so in this way that we can perform a data transformation pipeline steps. After that we have our model trainer. So yes, here we have a model trainer. Now again that we are going to import the class, all those things, we are going to create a model trainer class, we are going to function a configuration manager, we are going to call a get model trainer config, and then we are going to call the model trainer class, and where we are going to pass our train function. Okay, now we have an entry point, and then we are going to run our model trainer pipeline. Same way whatever the stage that we have started from the data ingestion, data validation, model training, data transformation, so on, for our model evaluation as well. So let me show you the model evaluation, the last one. So first again we are going to import all the library, we are going to create a model evaluation class, model evaluation training pipeline class, we are going to create a function, and with the help of this particular function we are going to call the model evaluation class from our model evaluation.py file, and then we are going to call a log into the MLFLOW function. Okay, and after that we are going to run our model evaluation pipeline. Okay, now all the files that I have associated with our main.py file. So if I show you here, so as you can see from here, first of all that we are going to import our all the class from our pipeline folder. So as you can see, a pipeline folder, from the pipeline that we are going to call the stage 1, stage 2, stage 3, stage 4, stage 5, and from here we are going to call our all the pipeline class. So data ingestion training pipeline, data validation training pipeline, data transformation training pipeline, and the so on for our all the class. Now after that, one by one that we are going to call all the stages. So data ingestion stage, data validation stage, data transformation stage, so on for the model training and the model evaluation. After that, whatever the function that we have, this particular objective function, so we are going to call this particular objective function from our all the pipeline in our main.py file to run our all the training pipeline. So as you can see, this is the main.py file that we have. So yes, data ingestion, data validation. Apart from this one, these are the logs that we are going to call, right? So these are the logs that we have. Now data transformation, here that we have the model trainer, and here we have our model evaluation. Okay, so one by one that we are going to call our all the pipeline. Okay, so now what I am going to do, so let me open my terminal from here. This is the terminal that we have, the new terminal. From this particular new terminal, make sure based upon this particular readme file, first of all try to create an environment and activate the environment and install your all the requirements.txt file. Okay, now what I am going to do, first of all I am going to select my command prompt from here. After that I am going to activate my environment. So conda activate env. Okay, now as you can see we are able to activate our environment, so it will take a few seconds. Yes, done. Now what I am going to do, so here we have our artifact directory. Okay, so now I am going to delete this particular log directory. Okay, so let me delete this particular log directory right now first. After that I am going to delete this particular artifact directory. So let me delete this particular artifact directory because I am going to run my training pipeline. Okay, so that's why I am going to delete, so that you can check it out our complete output. Now what I am going to do, this is the main.py file that we have our complete training pipeline. So we are going to run this particular training pipeline. Even that I am going to delete this particular runs folder as well. Okay, so let me delete this particular ml runs folder. So we are able to delete our all the files. Now let me run our python main.py file. So python main.py, we are going to test our complete pipeline. Now as you can see, we are able to get our logs file. Under the logs, that we have the running logs.log file. Okay, now let's wait few seconds. After that, it will start the execution from our first pipeline called data ingestion, data validation, data transformation, model training, model evaluation. So each and every pipeline that it will execute one by one. So let's wait few more seconds till the execution. Meanwhile, let me check it out the file. So yes, right now we did not have anything. So let's wait few seconds. It will take some time to do the complete execution. Okay, so let's wait few more seconds till the execution. Then I will show you the complete output in this particular log file. And whenever it will start the execution, then we will get our artifact directory as well. So under the artifact directory, that we will get our complete output called data ingestion. Now as you can see, now execution is started. So here as you can see, stage data ingestion started, config file loaded successfully, params.yml load successfully, schema.yml load successfully, created the artifact directory, created the artifact data ingestion directory. Okay, so if I show you here, so as you can see here, data ingestion completed, data validation, let's check a status. So yes, true. Data transformation, we have a 3D file, model trainer, we have a pickle file, model evaluation, we have our complete accuracy model. So we are able to perform, or we are able to successfully run our complete pipeline. Apart from this one, if I show you here, so as you can see, let me close this particular artifact. Here we have our ml runs folder as well. So in this particular ml runs, we have our 0 directory, and under this particular 0 directory, that we have our metadata.yml. So in this particular metadata, that we are getting our complete information. So artifact location, creation time, experiment ID, last update, life cycle stage, and the name. Now if I show you here, so as you can see, this is the our run ID that we have, run ID directory, where we have our artifact, complete artifact, the conda.yml, ml model, and under the conda.yml we have our complete information like dependencies, pip dependencies. Okay, now we have our complete ml model. So this is the complete ml model information that we have, the artifact path, model, flavors, a python function, conda environment, a virtual environment, python version, sklearn version, MLFLOW version. So each and everything, the complete information, model UI ID, run ID, UTC timing. So each and everything that we are getting, a pickle file, python env, yml. So again a dependencies, a complete build dependency, requirement. So whatever the important requirement that we have, each and everything that we are getting, matrix wise. So accuracy that we are getting 100, as you can see, the 100% accuracy. Parameter wise, as we are using 2 parameters, so mini split, as well as any estimator that we are getting. Tags wise, a metadata tag. So yes, a complete information that we are getting here in our MLFLOW. Okay, so right now we are able to train our complete machine learning algorithms, and even that we are able to capture a complete information in our log directory as well. So this is the complete information that we are getting in our log directory. Now what I am going to do next, after a model training and after building a complete application, now we want to build our application. So till now that we are able to train our complete pipeline. Now whatever the pickle file that we have, as you can see here, that we have our pickle file in this particular artifact directory under the model trainer. Now based upon this particular pickle, this joblib file, not a pickle file, a joblib file. Okay, so based upon this particular joblib file, that we are going to build a Streamlit application. Okay, so I'm going to build a Streamlit application. So to build a complete Streamlit application, here we have our application.py file. Okay, so before this one, let's try to understand our complete prediction pipeline. So here that we have the prediction pipeline directory under our src, and here we have our prediction.py file. So in a prediction.py file, what we are going to do, first of all, we are going to import our all the library. So these are the important library that we have. After that, we are going to create a class, a prediction pipeline class, where again we are going to define a constructor, and then we are going to load our complete model, our joblib model from our model trainer directory we are going to load. Now we are going to create a function, so define a function to predict. So this is the complete function that we are going to define, and then we are going to call a prediction model based upon our model. Okay, and the output that we will get into the integer. Okay, so this is the complete prediction class that I have created. Okay, now what I'm going to do, so let me jump into our application file. So this is the application.py file that we have. Let me below our terminal right now. Okay, now what we are going to do, so first of all we are going to import our all important library. Okay, now after that this is the streamlit that we are going to use. So set page config, so page title, icon, layout, as well as the sidebar that we are going to set. Now title by mushroom classification, header that we are going to set, and we are going to select a select box where we are going to choose a option home page, a train model. Okay, so I want to train the model or I want to do the prediction. So these are the complete select box option that I am going to select in my streamlit application. Okay, after that, if app mode, this particular app mode equal to home, in this case that we will get the output, so welcome to the mushroom classification app. So this is the message that I am going to print over our streamlit application if our users they are going to select the home page. Let's say if our users they are going to select the train model, in this case what we are going to do, so if app mode equal to train model, it means that we will get our train model button, and after that we are going to call our system python main.py file. So the python main.py file that we have, this one python main.py file. So with the help of python main.py file that we are going to do a complete training, and after that, after successful, then we will get the message called training successfully. Okay, so this is for our training model and this is for our home page. Now next that we have our prediction. So if our users they are going to select the predict option, in this case set the right fill in the mushroom features to make the complete prediction. So here we need to select the complete option, and based upon this particular option then we can do the complete prediction. So based upon our data, what we are going to do, so we are going to select our complete features. So cap zip, cap service, cap colors, brushes, orders, GIL attachment, GIL spacing, and so on. We are going to select our complete option. So as you can see, st.st streamlit.select box, and then the ranges that we are going to define. So ranges that we are going to define for our all the data. Okay, now what we are going to do, so here we are going to create a complete features list. So complete features list that we are going to define. So features list equal to our complete all the features list that we are going to define from here. Now one thing you need to notice here, so as you can see everywhere that we have the range called list range 1 to 11. So what you can do, you can do the modification here little bit based upon our data. Okay, so I have selected the same types of the features so that I can show you the UI as well, but here you need to do the little bit modification, because in a some of the column that we have the 4 features, in some column that we have the 8 features, some column that we have the 11 features, 7 features, 5 features. So based upon this one you need to define the ranges, a little bit modification you need to do. Okay, now after that we are going to call our all the features list. So yes, these are the all the features list that we have. Now we are going to reshape it into the numpy array, and then if st.button predict, in this case that we can call the complete prediction pipeline, and then we will get the complete output. So 0 it means the edible and 1 it means the poisonous. So this is the complete output that we are getting. Okay, so now what I am going to do, let me open our terminal again. So this is the terminal that we have. Now in this particular terminal, what I am going to do, first of all I am going to clean my screen. Now I am going to run our streamlit application. So streamlit run app.py file. So this is the application that we are going to run. Let me press the enter button, and whenever I press the enter button I will get one of the link. So let's wait a few seconds till the execution of our link, and then we can do the complete testing. Okay, so let's wait few more seconds till the execution, and then we can test our complete application. So yes, it will take few more seconds. Yeah, now we are getting our complete link, a local URL as well as a network URL that we are getting. Okay, so now what I am going to do, so let me open this one. So here as you can see, this is the complete URL that we are getting. Okay, so this is a complete our streamlit application that we will get here. So let's wait, as you can see it's running. So it will take few more seconds. So let's wait. Meanwhile we can check it out our terminal. So yes, it's running as you can see on this particular URL. So let's verify once. So yeah, right now it's running. So let's wait few more seconds till the execution, then we can do the training in our terminal, not a terminal, in our UI itself, because we have one button called training pipeline. If I show you again here, so as you can see this is the application.py file that we have, and in this particular application.py file, if the users they are going to select app mode equal to train mode, in this case that we can do the complete training. Okay, So yes, it's taking some time. I don't know why, but what I can do, let me copy this particular link and let me open my browser meanwhile. So let me close both the link and then I'm going to paste the new link here. Let me close my previous link because I don't know why it's taking lots of time. Let me close this one. Hope now I will get easily. So let's wait few more seconds. So this is the development. Yeah, this is the warning that we have, so we can skip. This is totally fine. Meanwhile, let me check it out in our terminal itself. So yes, this is the terminal that we have. Let's wait few more seconds. Now as you can see, this is our complete Streamlit application we have. So mushroom classification, and welcome to mushroom classification app. Why? Because we have selected the home page. Okay, as for our application, so if I show you our application.py file, so if our users, they are going to select the home page, in this case that we will get the output called welcome to the mushroom classification app. Now what I'm going to do, I'm going to select a train model section. So let me select, so choose option. Here we have our train model. Okay, now here mushroom classification and train model. So let me click on this particular train model option. Now as you can see it's running. Let's verify in a terminal. So let's wait few more seconds. Let me check it out the last log from here. Okay, so it will start in a few seconds. So let's wait. Right now it's running, as you can see here that you can check it out or running. Okay, let me check it out in the terminal. Meanwhile, even that we can check it out our data ingestion file as well. So yes, let me check once our this particular file. So right now as you can see, now it's started this particular training. As you can see, training started. Even that we can verify in our terminal as well. It's running, right? Let me check it out a terminal. So yes, model evaluation logging into the model file, and now as you can see JSON file saved, model evaluation matrix.json. Okay, now if I show you the ML run, so under the ML run, now we have a 0 directory, and under the 0 directory now we will get a 2 directory, 2 run id directory that we will get. So yes, 2 run id directory that we are getting, even that artifact wise. So we are getting our complete output here under our artifact directory. Now if I show you our UI, so yes, as you can see this is the UI that we are running. Why? Because here some of the part is pending right now. So as you can see the artifact model evaluation, now we are getting this one a JSON file saved. Okay, so let's wait few more seconds. Let's wait few more seconds, then that we can check it out. Now as you can see stage model evaluation stage is completed. Now let's verify in our UI. So yes, this is the UI that we have, and the training successfully. Now if we verify here in our application file, so after the successfully, then we will get the message called training successful. Okay, now what I'm going to do, let me open our UI. Now from here that I'm going to select the predict option. Now this is the complete prediction option that we have. So I'm going to select the by default option right now. You can just check it out from your end. And now let me click on the predict. Okay, so as you can see it's running. It's running here right now. So let's wait few more seconds till the complete execution. Now as you can see prediction is poisonous. Okay, so yes, this is our complete mushroom classification project pipeline application that we have. Now it's time to log. We have already logged our complete MLFLOW. Okay, now what we are going to do, now we are going to test, now we are going to visualize. So what I'm going to do, let me interrupt our application right now. Okay, now let me clear the screen. Now here I'm going to visualize my complete MLFLOW information, whatever the information that we have in this particular to run id. Okay, so for this one that we can write here MLFLOW UI. So this is the command that we have, and based upon this one let me press the enter button, and within a some time that we will get one of the link, and based upon the link then we can access our complete MLFLOW. Okay, so let's wait few seconds till the execution, and after that we can visualize each and everything. Okay, so let's wait few more seconds here. It's running, so yeah, it will take few more seconds because as I'm using the OBS to do the recording, so that's why it's taking some time. But yeah, now we are getting our serving link. So now what I'm going to do, I'm going to copy this particular link from here. Let me copy, let me open my browser, and after that I'm going to paste this particular link in my browser. So let's paste here. Now as you can see, this is the MLFLOW experiment ID that we are getting. So experiment here, as you can see, a 16 minute and the 2 minute, because right now that we have trained one with the help of Streamlit and one that we have trained 16 minutes ago, right? So 16 minutes ago. Now duration 40 second and the 42 second with the help of main.py file that we have trained both the file. Okay, here we have our complete scale and model. So scale and model that we are getting. Now what I'm going to do, I'm going to select one model from here. Now here as you can see, we have our complete parameter, whatever the parameter that I have used. So mean simple split, n estimator, matrix, and then artifact. So in our artifact that we are getting our complete model. So this is the complete model information that we have, our complete conda.yml information, complete dependencies information, pickle file. We have our complete Python env, where we have our complete dependency and the requirements. Okay, now if I go back again, so let me go back in experiment. Here we have our second one. So if we want to visualize, in this case that we can select each and everything and we can compare. So here we have our accuracy. Let's say if you want to select any parameters, so in this case that we can select the parameters and then we can do the complete visualization. Okay, so this is the parallel coordinate plot that we have. This is the scatter plot, because as you can see, this is the complete n estimator that we have, 100, accuracy 1, and the mean sample split that we have the 2. Okay, now if I talk about the box plot, so yes, this is the, okay, so box plot that we need to select the x and we need to select the y. So yes, this is the box plot where we have the accuracy 100%. Now let me select with the help of mean sample split. So yes, mean sample split, and this is the complete graph that we are getting. Now the contour plot, so again that we need to select, and based upon this one that we can visualize each and everything. Okay, now what I'm going to do, I'm going to show you one more things here. So here we have a 2 model, how we can put it down for the final production. Okay, so in a model that we have, as you can see, we have the model, and right now as you can see in this particular model that we have the name, a latest version, staging, pre-production, last modify, and the tag. But each and everything that we have the empty right now, we have a empty right now. So now what I'm going to do, I'm going to select the experiment. I'm going to select one model from here, and after that as you can see here we have the registered model. So I'm going to select the registered model here. Let me create the new model. Okay, and let me write a name called mushroom, or let me write the classification. Okay, now registered. As you can see, classification version 1. Okay, now what I'm going to do, let me go here, let me go over the model section. Now as you can see in the model section that we have the latest version 1. Let me click on this particular version, and right now as you can see stage that we have the none. So now what I'm going to do, whatever the model that I have selected a version 1, now I want to put it down this particular version 1 in a deployment. So what I'm going to do, I'm going to click on this particular version. Now I'm going to put it down our version 1 model in a deployment section. Okay, so from here that we can select the staging, and let me put it down transition into the production. Let me select the production, and here transition to the production and transition existing production model to the archive. So okay, now as you can see stage is production. Let's check it out, a classification model. Now as you can see the version 1 that we have into the production. Let me click on the model. Now as you can see the version 1 that we have, the version 1 model that we have in a production. Right now that we have the only one version. Now what I can do, let me click on the experiment. Let me click on the here in our second model. Now a registered model, select the classification, and let me put it down a register. So now we are going to select the version 2. So as you can see a classification version 2. Okay, so this is the second model that I have selected. Now let me click on the model. So version 2 that we are getting here, a version 2, version 1 that we have in a production, but the latest version that we have the version 2, and the version 1 that we have in a production environment. Now let me click on the version 2. Now right now as you can see the version 2 that we have nothing, a stage is none. So now what I am going to do, let's see the second model, a version 2 model that I have 100% accuracy, and the version 1 that I have the 90% of the accuracy. So now what I want to put it down my version 2 model into the final production. So now what I'm going to do, let me click on this particular here. Now a version 1 that I'm going to put it down my version 1 into the archive or into the staging environment. So let's say I'm going to put it down into the staging environment. Okay, so okay, staging environment that we have. Now let me put it down the model again. Now you can see a version 1 that we have into the staging environment, production environment that we have the empty right now, and the latest version that we have the version 2. So now what I'm going to do, now I am going to put it down stage version 2 model into the production. So let me select here version 2, select from here to version 2 and then okay. Let me click on the model again. Now as you can see, the latest version where that we have the version 2, and in a production that we have the version 2 model, and the version 1 that we have right now in a staging environment. Okay, so in this way, let's say that we have the multiple environment, so based upon multiple model and based upon the accuracy, if we want to put it down into the staging or the production or the archive environment, in this way that we can do manually. This is the manually that we have done. We have the another way as well, with the help of a script, a MLFLOW script, then we can do it. Okay, so in my upcoming project that I will show you how we can put it down a model in a different environment. Okay, so yes guys, this is all about a more MLFLOW integration. Now one more thing that we want to discuss here. So here that I have one of the app.py file. So here that I have created a complete application for you mainly. Okay, now what you need to do here with the help of this particular app.py file, you need to create the index file. Okay, you need to create the index file, you need to create the train file, and you need to create the predict.html file. And based upon this one, you can integrate this particular application, a Flask application, with the help of HTML and CSS web application that you can create. So it's totally up to you. If you want, you can do it. Else we have our application.py file with the help of HTML. You can integrate with this one as well. Okay, now we have here Docker file as well. So here that I have mentioned the complete Docker code. So if you want to integrate with the Docker, then you can integrate it. So we have our complete code here. If you want a complete Docker integration, let me know in a comment section. Okay, so I will try to integrate this particular project with a Docker file as well with the complete implementation, and then I will upload a video. Okay, so yes guys, this is all about our complete project, a first project where we have done the complete integration with the MLFLOW. Make sure guys, please like the video, subscribe the channel and share with your friends guys. Thank you so much. See you in our upcoming project. Thank you.